Hey everyone. So now that we know about the real numbers, we're going to start discussing what the properties of the real number. We're going to start with this guy, which is the commutative property. So there's a commutative property for addition, and there's a commutative property for multiplication. The addition commutative property says that a plus b is equal to b plus a, and the multiplication commutative property says that a times b is equal to b times a for any two real numbers a and b. These are restricted to addition and multiplication. And it's important to note here that the commutative properties are particular to addition and multiplication. So you might be asking yourself, okay, well, what about subtraction? Does that have a commutative property? And if we just look at an example, let's say 3 minus 5, compare that to 5 minus 3. 3 minus 5 gives us negative 2, whereas 5 minus 3 gives us positive 2. Now, obviously, these two ain't equal, so no, subtraction does not have a commutative property. So what about division? Does division follow the commutative property? If we look at an example, let's say 16 divided by 4. Well, that one's easy enough. It's just 4. If we look at 4 divided by 16, we actually get a decimal fraction, 0.25. And again, those two are not the same. So subtraction and division do not have commutative properties the way that addition and multiplication do. Next up, we have the associative properties, which are maybe a little bit harder to digest, but we'll look at both of them. For the additive associative property, we have A plus the quantity B plus C is the same as the quantity A plus B plus C. And similar for multiplication for all real numbers A, B, and C. So the associative properties really have to do with grouping. Whereas the commutative property said, I can switch the order that I'm doing the operation and everything's fine. The associative property says, okay, if I have 3 or more that I'm performing the same operation on, I can group them into any pair that I want and still get the same result. So it doesn't matter if, according to PEMDAS, I do B plus C first or I do A plus B first. I'm still going to get the same answer in the end. Same for multiplication. Next up on the properties, we have this notion of an identity property. So both addition and multiplication have their own special values called identities that never change a particular number. The additive identity would be 0, and that's because A plus 0 is 0 plus A is equal to A for any real number A. So no matter what you add 0 to, it's going to stay the same. For the multiplicative identity, it's 1. So A times 1, 1 times A, they're both going to give you back A again for any real number. No matter what you multiply by 1, you're getting the same number back. Next up, we have the inverse property. And these are a notion of undoing addition and multiplication. So for addition, we have what's called the additive inverse. So the additive inverse for a number A should be a number that I add to A to get 0. And it's pretty easy to figure out what that number is. It's negative A, or the opposite of A. So for addition, the inverse of a number is its opposite. As far as a multiplicative inverse, for any real number A, which is not 0, when you multiply a by 1 over a, you get 1. So the multiplicative inverse of a non-zero number is always going to be its reciprocal. 0 being excluded from this definition does not have a multiplicative inverse. And on the subject of 0, let's talk about it. So the number 0 is really special, and it hasn't been around since the beginning of mathematics. This idea had to be introduced at some point. So not only is it the only number that is neither positive nor negative, it has some special properties. For any real number a times 0 always gives you 0. So in other words, 0 annihilates any number by multiplication. And for any real number a that's not 0, taking 0 divided by a also gives you 0. And for any real number a, the quantity a divided by 0 is undefined. So it doesn't matter if a is 10, or negative 25, or negative pi squared, or 0. Quantity a divided by 0 is not defined. Division by 0 is undefined. There is a little bit of nuance because a divided by 0 is undefined for different reasons when a is 0 versus non-zero. But that's not super important, so we won't get into it. All right, so now what we can do with these properties is use them to make our lives a little bit easier. Normally, in simplifying an expression, following the order of operations, since we have addition here, we're going to add from left to right. But employing the commutative property allows us to switch the order of the expression without worrying. So I can switch around the negative 75n and the 84n. And then I can observe, hey, 84 and negative 84 are opposites. So according to the inverse property, this is going to give me 0 times n plus negative 75 times n. And I know 0 times anything is 0, so really I'm just left with negative 75n, and that's a lot easier than just going straight left to right. If we have something like 0 over y plus 5, and we want to simplify it, well, we know that 0 divided by any number which is not 0 is going to be 0. Since y isn't negative 5, this means y plus 5 is not 0. So this simplifies pretty nicely down to 0. And finally, we have a quantity 10 minus 3p over 0. Anytime we see division by 0, we should be very quick to recognize that the operation is undefined, and there's nothing else to be done here. And that about wraps it up for this video.